In this video, we will learn to solve different kind of numerical problems based on electrostatic formula, laws or principle we have studied till now. And here is the first question we are going to solve. You see that a polythene bag acquired this much of charge, and this much of charge is acquired due to the transfer of electron, and if it is taken positive, that charge has been the electrons have been transferred from the body, therefore that's why it has again. And now think which principle this uses, and number of electrons has to be find out how many electrons have been transferred to acquire this much of electron. So which principle it uses? The electron transfer, that is quantization of charge. Suppose the total number of electrons transferred from body is n, and each electrons has charge 1.6 into 10 to the power minus 19 coulomb, then total charge will be this much, q equal to Ne, and this is based on the quantization of charge. So on solving N equal to Q by E, we get this number of electrons have been transferred from the body. Next part of the question is that, is there a transfer of mass? Yes, since there is a transfer of electron and each electron has a mass of 9.11 into 10 to the power minus 31 kg. So if charge have been transferred, that means electron have been transferred, and if electron have been transferred, then this much have mass have been transferred. So there is a transfer of mass. So answer is yes. What is the next part of that one? If yes, so your answer is yes. Then calculate increase or decreasing mass. So electron have been transferred from the body, so mass has decreased because each electron has mass 9.11 into 10 to the power minus 31 kg, and there are this number of electrons have been transferred. So total mass transferred will be number of electrons into mass of each electron, and finally it is 1.7 into 10 to the power minus 18 kg. In the next question, we have to find the least Coulomb force between two charges separated by a distance. So first of all, think which formula you have to find the force between two charges. That is the Coulomb force, Coulomb formula, that is F equal to 1 by 4 pi epsilon naught. I have taken 1 by 4 pi epsilon naught because the question don't have any specific medium, and if there is no medium specified, then you have to take it as epsilon naught, and q1 q2 the two charges divided by r square. This is a constant, and we know that its value for air is 9 into 10 to the power 9. R, it is already fixed, it is 1 meter. Now the problem is that what is the minimum charge that we can have in free state. So the minimum charge, the least charge that we can have, that is E equal to 1.6 into 10 to the power minus 19 coulomb. So only finding this fact, you will be able to find the minimum force between two charges. So we have come to know what is the minimum charge that we can keep at a distance of 1 meter. It is 1.6 into 10 to the power minus 19 coulomb. So just put these things in this formula. 9 into 10 to the power 9, the two charges q1 and q2, that the least value we can have this much and this much, and divided by 1 square. On calculating, we will get this much of force. So the least force that we can create between two charges separated by distance is this much. Question. What we are going to do? We are going to compare the gravitational force and the electrostatic force between two given charges. So let the particles we have taken are electrons. So what is the charge on two electrons? That is q1 q2, and they must be equal 1.6 into 10 to the minus 19 coulomb, and the mass of the electrons are this much. So gravitational force will be calculated using this formula of Newton, and electrostatic force through this formula of Coulombs. So Coulomb force, when we calculate, I have not mentioned the distance. We can take a distance of 1 meter for both the cases, but I have taken only R. So the Coulomb force for these two charges will be 2.3 into 10 to the minus 28 by R square Newton. But the gravitational force for the same two charges, that is the same two electrons, will be 5.53 into 10 to the power minus 73 Newton. That will be Newton divided by R square. So to compare, let us divide the Coulomb force with the gravitational force. So finally we get approximately it is 10 to the power 45 times the gravitational force between the two electrons. So Coulomb force is a stronger force, much stronger than the gravitational force of the two electrons. This fourth number of question, what will happen if a different medium is inserted, either completely or partially a different medium is inserted between the two charges is there, then how the force between the charges will change. So for that, suppose that when there is only air between the charges, the formula we must use this one, and if there is another medium between them, the formula we must use this one. This formula has another constant K, that is dielectric constant, and dielectric constant is also called relative permittivity. Least value of permittivity of K is 1 for air or vacuum. So any other medium that will have K always greater than 1 for any other medium. So if the least value of K is 1 for air or vacuum, you remember it, and if any other medium is inserted between the charges, that K will have more than 1 value, more than 1. So dividing the force between the two charges, same two charges when it is in medium, divided by force between the same two charges when it is in air, it gives 1 by K, and K is greater than 1. So this fraction will be less than 1, and on solving this we find that the force between the two charges when a medium is inserted between them is less than the force when the medium between the charges is air or vacuum. Here is the fifth problem, in which there is a Q, and each corner of Q has a charge of Q, and Q. We have to calculate the total force on this third charge Q due to all these three charges. So first of all, see what will be the force on this third by fourth, that is represented by force on third by fourth, and that we have calculated 1 by 4 pi epsilon naught Q square by A square. Let its value is F. This value I have represented with a sign F. Now the force on this third by this second one, that will be repulsive and in this direction, and that is again F 1 by 4 pi epsilon naught Q square by A square, distance square. So the result of these two forces will lie along this direction, because they are symmetric. These forces are equal, so the parallelogram that we will draw will be the result will be in the diagonal direction. So the total result of these two forces, F34 and F32, will be in this direction, that is Fr, and it will be root 2F. I am not going to use this one because to make it simpler I have taken this value as F. So total resulting force at this point will be root 2F. Now what is the force? What is the force on this third charge by this one? So what is the distance here? It is root 2a. So the force on third by 1 is 1 by 4 pi epsilon naught Q square by distance square, that is root 2a. So it is 1 by 2 1 by 4 pi epsilon naught Q square by A square. So total force, this value has symbol F, so F by 2. So F total will be F total force, since this force F31, because the first on third will be in this direction, and because of these two forces the result will be in this direction. So the two forces we can add up directly. So F31 plus Fr. So what is F31? It is F by 2, and what is resulting force of these two forces is root 2F. So write it root 2 F, take F common, you will get F, and this is 1 by 2 plus root 2. You can solve it further. F by 2, and this is 1 plus 2 root 2. Now you put the value of F from here. F equal to 1 by 4 pi epsilon naught Q square by A square. Here is the last problem. In this problem, two similar objects having equal charge Q are suspended through two inextensible string of length L. So because of their electrostatic force, they repel apart from each other and make some angle theta. So if this the length of the string I have taken L, so the both length is L, so this length will be L sine theta, and this length again L sine theta. Theta is the angle the string makes with the vertical. So how many forces are acting on each of them? So let us consider this one. So this object has a tension T along this string. So this string has a tension force T along this line, and another force that acts on this body is weight mg, that will be acting downward, vertically downward, and a third, that is Coulomb force along the line joining the charges. So these are the charges, and they are positive, so or they are similarly charged, so they repel each other, and this force will be along this direction. So first let us calculate the force. F equal to 1 by 4 pi epsilon naught Q square and distance square. So what is the distance between them? That is L sine theta, 2L sine theta. So I have taken 2L sine theta square. So F equal to 1 by 4. This force is for 2 square, 1 by 4 into 1 by 4 pi epsilon naught Q square by L square sine square theta. Since this object or this charge is in equilibrium, so we can use Lemmy's theorem. So to apply Lemmy's theorem, first of all we have to find the angle between all these forces. So this mg and F has an angle pi by 2, acting at an angle pi by 2, and tension T, since this angle is theta, so alternate angle, this angle is theta, so total angle from here to here between force and the tension is pi by 2 plus theta. And what is the angle between mg and T? That will be, total angle is pi and theta is reduced, so total angle is pi minus theta. Now T and its vertically opposite angle is pi by 2, so T by sine pi by 2. F, that is F, and its vertically opposite angle is pi by 2, pi minus theta, so F by sine pi minus theta. And mg, its vertically opposite angle is pi by 2 plus theta, so mg by sine pi by 2 plus theta. So here is the equation, and using any two at a time you can have a one equation. So first of all let us take this and this one. So taking this and this two equation, I get T equal to F by sine theta. So here is the equation you can solve. Taking F by sine pi by 2 pi minus theta and mg sine pi by 2 plus theta, I solved till tan theta equal to F by mg. And the third equation you will get by solving this and this one. So T by sine pi by 2 and mg sine pi by 2 plus theta. On solving this you get T equal to mg by cos theta. So using these three equations, whatever you want to find out you can find. So check your question, what is to be find out there, and solve these three 1, 2 and 3, and you will get your answer. Thank you.